I'm one dog, the dog,
Hey, welcome everyone. I'm Mark Hughes. I co-chair the Hospital Ethics Committee. I want to welcome you to the May Ethics for Lunch. Good to see a great turnout today. The Ethics for Lunch, as you all know, some of you are regular participants, is sponsored both by the Hospital Ethics Committee as well as the Berman Institute of Bioethics. And for those that are getting CME credits, I need to go through some initial slides just to tell you a little bit about the process. So this is accredited and through our Office of Continuing Medical Education. And our general objectives, so this is open to the whole hospital community. And general objectives are just really to provide a forum for education and those are the other objectives. Today, there are no individuals with any conflicts of interest. And what we're going to be talking about today is xenotransplantation. These are the specific objectives with regard to talking about the organ shortage crisis. We're not going to be talking about particular patients, but for those that where we might mention anything that might be related to a patient, we just want to make sure we respect confidentiality. If you are interested in getting CME credit, there's this number 1-844-980-1555, and the code for today is 57928. So just text that in, and you need more information. Is available on the CME website. All right, so it's available on that website, and I will turn it over to Dr. Anna Hamlin, our director for the Department of Surgery.
Thank you, Mark, and thanks everybody for coming out. I appreciate it. I'm Andrew Cameron. I'm a transplant surgeon at Hopkins. I've been doing that job for about 20 years. I was a medical student before that. And thanks. We'd like to take 20 minutes of your time, half an hour, and talk about this interesting topic and get your thoughts on your input. I want to thank the other folks that agreed to come out and discuss the topic. Two experts, Olivia Cates and Jeff Aaron. Thanks, guys, for appreciate your help and support in this endeavor. So let's dive in. The topic is xenotransplantation, or using animal organs to try and solve the organ shortage crisis. All right, this is the problem, and it is a public health crisis. So you don't even need to read it. You can see it from the back of the room. The line going up and away is the number of patients that are waiting for a transplant, or in this case, a kidney transplant. There's probably 120,000 Americans waiting for an organ transplant right now. The flat lines at the bottom are the number of organ transplants we do. They're not going anywhere. This line's going up. The difference is people waiting on the list and dying on the list. So we'll have a nice conversation this hour. Somebody will die waiting for a transplant that never comes. So 20 people die every day, not because they have a horrible cancer that we can't fix for 2025, just because there aren't enough organs. So as that's a public health crisis. That's the problem. So, when we go to bed tonight, our current solution isn't good enough. 20 people die every day. So we're going to talk about a novel solution, and it's going to have its shortcomings as well, but it is a crisis and it does demand new approaches. All right, that's the crisis. Possible solutions. Well, not enough organs. We could spend the next hour talking about why people don't donate their organs, or why there aren't enough living donors, or whether we could use stem cells to rehabilitate failed organs, or 3D printing organs. I'm here for all of it. And I've spent a lot of the last 20 years working on some of those ideas. If one of those comes through, let me know. It'll be great, and we can start helping people more aggressively. Another horse in that race is an endless source of organs for transplant from animals. And if that sounds out there, like science fiction, I'm with you, there are some obvious disadvantages. I'm gonna give you like a 10-minute intro, and then we're gonna talk. So that's what we're doing. So this is the intro. This is everything you need to know in 10 minutes about the idea of using animals for transplant. Obvious disadvantages. It won't work. Pigs, or depending on what animal we're gonna use, we could also talk about using non-human primates, monkeys, chimpanzees, baboons, as a source of organs. But they are different enough from us immunologically that you would reject an organ from a pig in minutes. So a regular farm pig will not work. You are immunologically different enough that you will reject it in minutes. It's not obvious that a pig kidney or liver, even if you didn't reject it, would work like a human. Organs are amazing. Your kidney filters your blood, your liver makes 6,000 proteins you need. Would a pig albumin or pig factor 7 or pig von Willebrand's factor work as well as human equivalents? There could be infectious risks, is the understatement of the year. We just got over COVID, worst pandemic in 100 years. That was when an animal virus jumped to humans. We don't want to unleash that on mankind, COVID 2.0. And there's ethical issues, which is why we're here this afternoon. You may not think it's okay to use animal organs for this cause. That's happy to discuss that too. Or you may think it's too great a risk to the human recipients, I suppose, or to the innocent bystanders that are next to the human recipient that didn't sign off on xenotransplant and could get infected. All right, that's the bad news. The advantages of using animal organs is that it would end the problem. That we wouldn't need to beg people unsuccessfully to donate their organs because there would be an unlimited supply of animals. In fact, these animals would be very, very healthy. I am 2/3 of the way through a liver transplant, and that donor was whatever we were able to get. It's sometimes a 65-year-old person that is obese and died of a stroke. Sometimes that person has hepatitis B or hepatitis C. I've transplanted livers with HIV. So you get what you get in the era of the organ shortage, and those donors are often unhealthy for sure. They'll die. And brain death has its own set of physiologic consequences. These pigs or animal donors would be incredibly healthy and well curated, and in some ways, perfect donors. And in some ways, they have a lower infectious risk because pigs don't get Hep B, Hep C, or HIV. And the pigs that we would use would be spotless. They would be perfect pigs, if there is such a thing. They would be carefully studied to make sure that they did not have a single infection. So it could be good if we could make it work. Talk briefly about pigs versus, say, baboons. Now, I told you if I used a farm pig today, you'd reject it in 2 minutes. I could sew a baboon kidney into you today, and it would work perfectly. So we are very similar to baboons and very different from pigs immunologically. So a baboon organ would work perfectly. You could do it today. All right, so that'd be good. But there are not enough baboons to go around. We need 100,000 organs. The number of baboons that are out there in captivity wouldn't meet that organ shortage crisis. Baboons are sort of like us, born one at a time. They got to grow up 20 years to donate their organs. That's no good. They're probably too small, believe it or not. Their physiology is close. You can't genetically engineer baboons. There would be infectious risk. And plus, I don't think anybody's going for it. I don't think anybody would sign off on the use of baboons for organ transplant. Pigs, on the other hand, they are immunologically much different than us. That's going to be a problem. There are functionally an unlimited number of pigs. Pigs are born in litters of 6 to 12. They reach maturity in 6 months. It would be very easy to sort of mass produce pigs. The organs are the right size. I think they probably work. We could talk about that. You can genetically engineer pigs, which is what we're going to talk about today. Infectious risk is very low. It turns out we've been working with pigs very closely on farms and the food industry for decades. And the public opinion we could talk about, but do you know we slaughter 100 million pigs for food every year in the United States? So we've kind of already crossed that bridge. Just for food that we don't need, we can all eat tofu or whatever you want. And so 100 million plus 1 to save a kid's life, I think will be okay. So probably it's going to be pigs. Sound like it's very far-fetched, it's been done. So I don't know if you guys would remember, that's Baby Faye, and that's Leonard Bailey, a pediatric heart surgeon in Southern California, who in 1984 sort of baboon liver into Baby Faye. And it was a big deal, it sort of caught the public attention, Paul Simon wrote a song about it. That's a picture of all the little kids that, Leonard Bailey saved. Baby Faye unfortunately only lived 17 days. So it kind of worked, but not really. And it's been done, but it's been dropped. It hasn't been done for 50 years. It was dropped until there was a big scientific breakthrough, and I'll keep this part short, but, what was it, 2001, this really neat guy, David Ayers, you've heard of knockout mice, not that hard to make, knockout pigs, very, very, very hard to make. To genetically engineer a pig in 2001 was a big deal. It took him 10 years to knock out a gene. What gene did he pick? He picked the gene that applies the antigen on all the blood cells in the pigs against which we have these naturally occurring antibodies. So everybody in this room would reject a pig organ because you have anti-pig antibodies. We can get into why you have those anti-pig antibodies. It's really interesting. You'll just have to trust me. But those pig antibodies are against a certain antigen, and the application of that antigen in pigs is mediated by that enzyme. I thought that if you knocked out that enzyme, the pigs would not have that antigen. The anti-pig antibodies wouldn't matter and would be all terror pieces. So this was 2001. Super excited. Xeno is going to save the day. This is David Ayers, this wonderful molecular biologist who developed these things. We had at Johns Hopkins to give a lecture. It was all very exciting, and it didn't work. Instead, those organs, instead of being rejected in minutes, were rejected in hours. So it was, better, but not nearly good enough. So we all had despairing. The joke was xenotransplant was the future of organ transplant, but always would be. It would always be just around the corner of science fiction. The real breakthrough came in 2010. I don't know if you've heard of CRISPR-Cas. It was a super interesting discovery in the early 2000s. Suffice it to say, it is a bacterial mechanism to fend off viruses, which clips DNA or RNA in a highly efficient fashion. And when it was fully appreciated, it was able to be used to very efficiently modify genomes. There's a great book about it. Walter Isaacson writes a lot of cool biographies. That's Jennifer Doudna at Berkeley, who basically was one of the key people that figured out CRISPR-Cas. That's her accepting the Nobel Prize in 2010 for it. We had a new tool by which you could snap your fingers and change the genome. Very interesting, very controversial. Should we modify human genomes? Should we knock out in little babies the HIV receptor so the kids can't get AIDS? Should we genetically engineer people? Not sure, pretty controversial. People not sure about that. Everybody was okay with the genetically modified pigs. And now, whereas it took poor David Ayers years to knock out one gene, we had a tool where we could knock out 10 genes tonight. So here's the new era. This pig is a 10 gene pig. So David Ayers had one genetic edit. This pig has 10 genetic edits. The molecular biology and the sort of veterinary medicines is actually very cool. But this pig has 10 genes knocked out. So here's one. The first one they knocked out was the same one that applied that antibody, the antigen against which we have antibodies. Turns out, David Ayers' pigs got rejected in hours because there wasn't just one antigen, there never is. Once you got rid of that antigen, you realized there were other antigens. But if you knocked out these three enzymes, you knocked out 95% of the antigens against which we have antibodies. So we knocked out 3 genes to make these pigs less pig-like. And then we added in 6 human genes to prevent clotting, to prevent inflammation, to prevent rejection, to prevent complement activation. 6 genes to make these pigs more human-like. And then there was a 10th gene. They knocked down the growth hormone receptor in pigs. Have you guys ever been to a farm and seen a pig they're checking? And people were worried that if you transplanted a heart or a kidney, the pig kidney would keep growing and be too big. So they knocked down the growth hormone receptor in the pigs. That's the 10 genetic edits. If this sounds like science fiction and it couldn't possibly be true, that's the pig. It's real and it's coming. So again, it's been done, and maybe you've heard about this part. The University of Maryland, just down the street, had a patient in their ICU. Mr. Bennett, shown here, who was about to die. He had heart failure, he was on ECMO, he was on repressors, intubated, about to die. And Maryland had decided he could not have a heart transplant. So they said, how about we sew in a 10 GE pig heart into Mr. Bennett? This is, I don't know, 2-3 years ago. They sewed it in. It worked. It worked like crazy. Mr. Bennett came off ECMO. Mr. Bennett came off pressor. Mr. Bennett extubated. Mr. Bennett's pig heart worked so well that he had to go on antihypertensives. And he was walking around the unit. I thought they were going to discharge him. I thought Mr. Bennett was going to throw out the first pitch at Camden Yards. I thought we were done. Thought it was over. We fixed it. No more late nights, no more people dying waiting for transplants. I thought it was like one of the great days in the history of medicine, New England Journal, all that. And after a month of happiness, Mr. Bennett's pig heart stopped working, and after 2 months he died. Which was a terrible disappointment for his family, for Mr. Bennett, for the team, for the field. When they looked carefully at Mr. Bennett's work of some interest, and it didn't stop working because of rejection. So that's actually exciting. It had a virus in it. It had porcine, it had CMV. Maybe you've heard of CMV. We all have CMV pretty much. But we have human CMV. This was porcine CMV, which is different. Porcine CMV does not infect humans, which is the good news, but it infects pigs. And Mr. Bennett's heart had latent porcine CMV at the farm, and it reactivated and his heart stopped working. So, but we can fix that. We can fix that. It was obviously a failed experiment, but it was in some ways proof of principle that we could do this. All right, I'm going to fast forward a little bit and let me do some of the talking. There had been 6 real live animal organ into human xenotransplants in what I'll call the modern era of xenotransplantation. Like Leonard Bailey 50 years ago, forget that. After CRISPR-Cas with modern pigs, there have been 6 transplants. So the University of Maryland did another patient after Mr. Bennett, and that guy lived also 2 months and died. And that guy died of rejection. That guy died when he had a bleed, and he got some blood product and FFP. And it turns out FFP has tons of antibodies, and some percentage of those are anti-pig antibodies. And he rejected after he got those blood products. So, we're figuring this stuff out. There have been 4 xeno kidneys done, 2 at Mass General and 2 at NYU. The first one done at NYU was a very complicated patient in the unit with a bad, it never really worked. The second patient did okay for about 2 or 3 months, and then actually became non-compliant. It's really complicated, didn't want to do it anymore. And the kidney was rejected and came out. Mass General, who have been working on this for 30 or 40 years, transplanted a 10 GE kidney, and it worked beautifully. And the person was discharged on day 9. And they went home and they were walking the earth with a pig kidney totally normal, like going to the grocery store. And they died in their sleep 2 months later of a heart attack. And it's not clear whether that was related to the xenograft or not. If Mass General did another one, that person's 5 months out and is fine. Still going. There's some other interesting stuff to see. So I'm about to tell you about what we've done at Johns Hopkins, and then I'll be done. So one way to test whether a xenograft work would be to stick it into a person and just cross your fingers, and maybe that is or isn't okay. Another way to do it is to test it by putting into a dead person. So stick with me here. If somebody dies and is up in the unit brain dead, but wants to donate their organs, they can do so. They may be medically inappropriate to donate their organs. Maybe they have, metastatic melanoma and can't donate, but they could be used as a recipient. And so at the University of Alabama and at NYU, they've taken brain dead decedents and used them as recipient for xenografts. And they put a pig kidney into somebody who's brain dead, family gave permission, and they kept that person going for 2 months and studied the performance of the xenograft. And were able to show success in that model. All right, we're almost there. So about 5 years ago, in our transplant division, we got very excited about what was going on in xenotransplant, and we recruited Dr. Kaz Yamada, who was at Harvard for 30 years, at Columbia for 10 years. That's Kaz all the way on your right in the white lab coat. Kaz has been studying xenotransplantation for decades. Here is Kaz. Kaz has a bunch of things he has studied, including co-transplanting the thymus, which is an organ that participates in immune regulation. Kaz transplanted the genetically engineered pig kidney into a baboon. Remember I told you baboons are very much like humans. They're so like humans, you could use their organs, or you could use them as recipients to test pig organs. Kaz put a genetically modified pig kidney with a thymus into a baboon. It lasted not minutes or hours, it lasted a year, suggesting that it would be a successful strategy. It was probably the nature. Okay, so what is the future? It's always the future. So the FDA has gotten very, very encouraged. We don't get to just do xeno. The government regulates it and gives us permission. The government agency that regulates xenotransplantation is the FDA. The FDA gives permission to do this work. Each one of those 6 folks that got a xenotransplant was an emergency Hail Mary case. The FDA gave emergency IND approval for one and only one case. You can do one transplant into specifically Mr. Bennett. Really what would be exciting is if we ran a clinical trial on xenotransplantation and got permission by the FDA, FDA approval to use xenotransplants in people. That's how we would get to 100,000 transplants. The FDA said in a meeting, you can do a clinical trial in humans if you prove to us that it's going to work. And to do that, you have to do 20 baboons. And if you can do 10 GB pig kidneys into 20 baboons and show that they all do fine, we'll let you do it in people. But you have to show us that first. So that was a couple years ago, and this is what we caught to Kajimata. We do these experiments. We get up in the morning, we fly down to the farm where the pigs are, which is in Blacksburg, Virginia. We procure organs, we bring them back to Baltimore, we sew them into baboons up on Playlock 12. That's me going down to Blacksburg. That's Mr. Bennett's cardiac surgeon. He would go down to get the heart. I would go down and get the kidneys. We'd fly back and Kaz would sew them into baboons. Every time we did a pig kidney into a baboon experiment, it cost $1 million. And that we can't afford $1 million. So the company that makes the pigs funded Kaz's lab to do this important work that was required by the FDA to have a clinical trial. Kaz, in fact, those 20 baboons did great. Kaz published that in Nature. That was super exciting. And now it's about time for a clinical trial. There are obvious risks to this. We've talked about infectious risks. I mentioned COVID. Their government has regulatory external oversight over whether this is okay for us to do or not. There are internal risks. Just because we can do this, should we do it? Is it a good idea to transplant, a patient with a xenograft at this point in time? The FDA gave us 2 months ago, in response to a presentation of Kaz's work, the FDA gave Johns Hopkins permission to start its own FDA-approved clinical trial in people. That is going to start in June. It's going to start in 1 month. We're going to do xenotransplants at Hopkins next month. So the specific clinical trial is for 2 xenotransplants to be done at Johns Hopkins, followed by another 4 to be done at Hopkins or NYU. And then if they went okay, another 44 cases here at Hopkins, NYU, and other centers to begin later. The people who will be enrolled in this trial are 2 groups of folks. People that are on hemodialysis and renal failure to Hopkins for a kidney transplant, and we're told no. So every week there's a patient selection committee meeting, 30 people, 20 get yeses, 10 get no's. The 10 get no's for various reasons. But if you're on dialysis for the rest of your life with no chance of getting a kidney transplant, you can talk about getting a xenotransplant. The other group are people that are on the Hopkins list and could get a human transplant tonight, but are mathematically more likely to wait 5 years untransplanted or to die before they get a kidney transplant. So if you get put on the list today, you can wait 5 to 10 years. And depending on your blood type and all this other different stuff, you're probably gonna wait 10 years in certain circumstances. If you're gonna wait at least 5 years or die in the meantime, you can apply for a xenotransplant. So the first case probably in June. That's it. That's it. That's the history. That's the first human organ transplant ever. Up at Brigham, I think 1954. This is the present. 20 people die every day. There's our little state of Maryland with a couple thousand people on the wait list. And that may be the future. And we are doing this not because it's exciting and cool science, which it is, but because it could potentially help the 100,000 people waiting for an organ transplant. That's Xena. Got it? And it's going to start here in Illinois.
Was that little pig you were, was that a full-size pig?
No.
That was a piglet.
Baby pig. They grow, even with the growth hormone receptor knocked out, they grow. They just don't grow into immense beasts.
You talk fairly specifically, particularly about the modifications that you had made to these pigs, but the question is, don't pigs have a short lifespan? Like, when do they live? 10, 15 years? And then how, is there some way to either modify them so they can live longer? Because certainly you want their organs to be viable for longer than that.
I think their organs would last indefinitely. I think even if, when a person or a pig dies, they often die of a specific cause, but they often die with healthy organs. And we know this because you could take a liver from a 65-year-old donor, put it into a 20-year-old kid, and it can last for 40 years. There have even been cases when that liver has been redonated and it's lasted another stretch of years. So there's no notion that a pig lifespan would limit xenotransplantation. That's a good idea.
Thank you.
Thank you, great job. Just wanted to know if you bring the organs closer to Hopkins, will you have more successful and better outcomes because the organ doesn't have to be.
Great question. So it is possible to bring the pigs here and donate here and use them here. That is possible for one-off scientific experiments. The government is going to require EPFs, designated pathogen-free facilities, for mass production of these organs. It's sort of industrial. It's like a Willy Wonka shop to make these pigs and their organs. So they're going to have to be only at certain specified, carefully looked after locations. The company is building DPFs. There's one in Blacksburg, one in Minnesota, one in California, one in Texas. They're going to be all over the place. And it's going to be boarding in the farm, organ procurements, drones of organs, out to transplant centers. The organs are gonna land, and at 10 o'clock, we're gonna sell them every day.
Can you move the baboons there?
But then forget the baboons. The baboons are a necessary evil, if you will. We don't want to really use baboons in animal research, but they are really the only legitimate model for whether these kidneys are working. Now that we're putting the organs into people, it's probably less relevant whether they work in baboons. This set of 10 GE, this is like beta 1.0. They're just getting good enough that they work. Talk to me in 10 years, it's going to be 10 different genes, or 5 of the same and 5 different ones. So we may need to keep testing the baboons, I can't tell.
Hi, so I worked in dialysis for 20 years before coming to Hopkins. This is incredibly exciting. See where this is going. My one concern, working with hundreds of patients, is how do we ensure they really understand what they're getting into? You're talking about patients that are desperate, that have no potential for treatment, that are cognitively affected by dialysis, that have a low understanding even to begin with of medical needs, right, that have been non-compliant, or, on and on and on. You understand the hemodialysis patient. So how do we ensure that they have a good understanding rather than, right, because you can say they sign consent,
If only we had a lawyer or an ethicist, something in this room. But I'm with you. I sign people up for operations and say, do you understand what you're getting into? And they sign the bottom of it. If I say, hey, you want the xenotransplant, are you sure you understand what you're getting into? They can't sign the piece of paper because I don't understand what they're getting. Nobody knows. And so I'm with you, that is the ethical dilemma, who goes first? If my daughter needed a kidney transplant, would I want her to have a pig? Or would I say stay on dialysis, or take an organ from a 7-year-old, or from somebody with Hep C? So that's what we're here to talk about, is how, in 10 years, I bet you, these organs will be ready for prime time, maybe even better than human transplants. How we get from here to there is a challenge. And who goes first?
How many people sign up for the transplant?
So I gave you the two groups. I sat in my office and called people that had been rejected by Hopkins. And I can tell you, I called 15 people. 15 people said, I'll see you in clinic on Thursday. This dialysis sucks, as you know, it's horrible. And if you tell them you're on dialysis for the rest of your life, or I have something behind 4B, then they want to know what's behind 4B, they want to sign up for 4B. Because dialysis is horrible. The people that, I called another 15 people that were on the wait list, but are more likely to die or have no transplant in 5 years. Those people, 13 of them said yes, seeing clinic. One guy said, no way. One guy said, I'll do it, but I don't want to be the first. Do a couple and call me back. Their strategy is very, very reasonable. And the other 13 said, I need dialysis and I don't want to wait for 5 years. And I've seen it on TV and it sounds like it might work. So I want to come in clinic and talk to you about it. So I don't know, whatever that number is, 28 out of 30 said yes. Anybody?
You guys in the audience just gotten a lot of information about xenotransplantation. Do you think it will work?
Can I ask a separate question? Sorry. I'm wondering with some religious groups such as Jewish individuals, and I'm sure others as well, where pork is not kosher. How does that work, or has that been explored? I have no idea, so I'm just curious.
Yeah, it has been explored actually. This was some of the earliest work in pig to human xenotransplantation. I think Jay Fishman did a lot of this research both with the communities and with religious leaders in Jewish and Muslim religions, and both groups have affirmed that they would be okay with this. This isn't consuming pork for like satiety or pleasure. This is using the resource of the land to preserve human life, which is the primary goal.
We still need pork valves.
Because the hamburger is pork based.
Yeah, there's also pig insulin.
Pig insulin, pig heart valves. I mean, we do, in some ways it seems far-fetched, in other ways we already do analogous things. That people can help, that may help some people understand it. Well, we give people pig heart valves, this is sort of like that, but it's the whole heart.
Hi, Dr. Cameron. So a few months ago, we became best friends with Timothy from Mass General. So we've been following his progress very closely. I wanted to ask your opinion on this. So as you know, he received the Genesis pig.
Yeah.
What is your opinion on the difference of these edits? Because I think that's going to be an ethical thing too, about who is the quote better edited pig.
So, this pig that we use, that Mr. Bennett got, and that NYU uses, and that we're gonna use, is from United Therapeutics, and it has the 10 genetic edits I described. Mass General uses a pig from a Massachusetts biotech company called eGenesis, which has 9 genetic edits. It has the exact same line, minus that growth hormone receptor 1. So those pigs and those organs could theoretically grow. But it's true, that's probably okay. Interestingly, that pig has another like 50 edits to knock out a certain pig virus, which they thought was important, but nobody else thinks is important. So there's going to be some heterogeneity of the product. It's like we're all in horse carriages. There's going to be this new thing called a car, and it turns out cars are going to be much better than horses. And there's gonna be Ferraris, and there's gonna be Volkswagens, and there's gonna be all types of stuff, but there's gonna be cars. So I don't know, I mean, again, I don't care what works, and let me know. If the eGenesis pig is better, give me that. That whatever pig you're using today isn't the pig you're using in 5 years, 10 years, like a Sony Walkman, probably nobody remembers that. Or a cell phone, it's just gonna get better, and it's gonna get better rapidly. I think competition between them sounds good. If there was just one pig, that would be the pig. If there were 20 pigs, may the best pig win. It'll all be for the benefit of the patients. And, the government will have to regulate it. But, we trust the government. Anybody else?
Hi, I'm actually a heart recipient of 10 years, and I really do think and believe it'll work. I also know Timothy from Massachusetts and New Hampshire. So it's going to work, but I had a question about, you mentioned 2 cases and then authorization for 2, then 4, then 44.
Yeah.
So what's the criteria, like, would they have to survive 8 months, or what's the basis for?
The FDA basically wants to see that nothing terrible happens. It's more of a safety study than an efficacy study. So I don't think that, in my mind, this is me talking off the record, if the organ lasts a year, it's a success. If we serve these kidneys in and they all last 4 months, I'll be very disappointed. And I'll say it's not ready for prime time. Another way of saying that is that I don't know that what the patient has to go through to get a xeno, which is immunosuppression and an operation and then probably getting removed. I don't know if that's worth it if it's only 4 months. The immunosuppression is the same immunosuppression you get if you get a human organ. That's a plus. If you need a xeno heart and you get a xeno heart, it stops working, you die. If you need a xeno kidney and you get a xeno kidney and it stops working, you go back on dialysis. So if we do it safely and carefully, in our trial, nobody should die. You should just get time off dialysis. You may say to me, hey, I got 4 months off dialysis, thank you. Or you may say it wasn't worth it. I would like you to get a year off dialysis, and then we can shake hands. That's my definition of safety. I think the FDA's definition of safety is nobody got a horrendous infection, nobody got a weird cancer that we didn't expect. That's safety versus efficacy. They haven't specified how long they want to see the organs last.
I just have a practical question. I'm a social worker, so is insurance gonna pay for this, or is?
Aetna, you'd be surprised, Aetna will not pay for it.
I'm not surprised.
The company has to pay for the clinical trial. Every Tylenol, every X-ray, everything, the company has to pay for, with the obvious hopes of getting FDA approval and then being able to sell their product. So these patients will not pay a penny, the insurance companies will not pay a penny, it's like many other clinical trials in that regard.
One follow-up. Have you learned anything from the most recent 2 kidneys from NYU and Massachusetts? Have you learned something that you'll be using?
So yesterday, I spent all day in a meeting with 50 people, and it was 20 people from Hopkins, 20 people from NYU, and 10 people from United Therapeutics. And we spent all day going over everything that is currently known about, the 6 folks that had a transplant, specifically the 2 at NYU. They told us everything they know. We told them everything we learned from doing 20 baboons. And the idea is we gotta give our patients the best shot possible. And so we can't be competitive in the silo. We have to share the information. And so far, so good on that. All the stuff that I talked about is all published. It's published in the New England Journal.
So this is, thank you. This is sort of a combined comment question. The question was posed, and I beg your pardon, I didn't catch your name, but you posed the question, do we believe that this will work? Which is obviously a very compelling question. I would suggest, and again, I'm a lay person, I'm the mom of a transplant recipient. I think that obviously the question, will it work, is fundamental, but it's not the only question. As a lay person, I feel so strong that there is just this enormous and growing gulf between research, science, and the public. And we know that the public's perception, unfortunately, the perception of science and research has been decreasing and we know that because of COVID, because of all this stuff we're dealing with the current administration, and we know reasonably it's likely to decrease. So the question and suggestion is, we know there is this gulf, even if this works, an area that I feel really needs to be addressed is public buy-in. And I think it is so important that the public understands better what the issues are. And I know it probably seems so old hat and it's just second nature to almost everyone in this room, but this isn't public. There is such lack of understanding. And for the public to buy in, I think there needs to be so much more in terms of public education. And now in this day and age where there are a million podcasts and X and this and that, it really seems incumbent to me that more is done to educate the public. And I'll end, I don't want to dominate, but I'll end by giving you an example because I can't tell you how strongly I feel this. When my daughter, when we were waiting for her transplant, the donor was an extended criteria donor. And I'd never heard of this. And I'm relatively well educated. I actually worked here for 17 years. I'd never heard of it. And when I asked questions, they were not answered in a forthcoming manner. And I said, stop. And I would not give consent for my daughter to undergo the transplant till I made a number of phone calls. And I wasn't educated about this. I think it is, again, I can't tell you how important it is. Not just does it work, but does the public buy in? Because, and again, I'm gonna end it with this. Look, there's a Dr. Frankenstein element to this, right?
Yeah.
I mean, you can't get away from it. It's there and it needs to be addressed. Thank you. I mean, you talked about on your committee. Do you have a family member? Do you have a patient? With great respect, I think you need, it is helpful to have buy-in.
Good luck to all of us. Everybody in this room agrees with you totally. We live in an America which is increasingly polarized and hard to understand. It's an America in which people don't want a vaccine that would save their life. Those same people, though, also, when they do not want the vaccine, lest they give in to the liberals, will show up to Hopkins short of breath and they'll take whatever you got at that point. And I think people on dialysis aren't going for that. They're going for tell me what you have to help me. But I mean, this is going to be a leap of faith. It's going to require public trust. Our ability to have the public trust experts in academic medical centers or universities is framed and it's being actively destroyed by the government as we speak. They are targeting us. Now, kidney transplant is weird. So there's Medicaid and there's Medicare. Medicare is free insurance for everybody over 65 and people with renal failure. The country's already decided that everybody in the United States gets dialysis paid for. When you do a kidney transplant, you get somebody off dialysis. And that ends up being a giant money saver for the system within 2 years. So kidney transplants and organ transplants, whatever your politics, are agreed upon to be a great idea for the patient and the government and the system. Everybody, you know, even our friends in Washington on either side of the aisle all agree that more transplants is a very good idea. You know, nobody's really against cancer care. So, but convincing the public that we're on their side, this is a good idea, we're not experimenting on them, and that this is to save lives. I'm with you, that's gonna be one of the many challenges that any innovation brings with it. But this is a far-fetched science fiction innovation that for some people might be bananas. And we're gonna have to talk people through that.
It is an experiment.
At this point in time, when we don't know what's gonna happen, it's not standard of care, we all agree on that. It has gotta be worked out. And so it's a clinical trial. Experiment is an okay word in this room, but like people might think you're experimenting on, that comes packed with tons of negative baggage, you know, especially here. I do dispute some of the semantics, but it's a clinical trial and we don't know what's gonna happen. That is why it is perhaps most palatable for people who have no other choice. The guy in Maryland who was gonna die this weekend without a heart, it was perceived as legit. And if you're on dialysis and you have no other option, maybe it's legit. But that's what we're here to talk about this afternoon.
Have you heard from animal ethics groups yet?
Yep, on non-human primates, on baboons, there's fierce, emotions. Not really from mice or rats at all. And I think pigs are more like mice and rats. Again, if you're anti the treatment of these pigs, go to SK Hot Dog Company and go talk to them. You know, I mean, again, 100 million.
I don't disagree. I'm just wondering what sort of.
It had, no, that hasn't, it hasn't happened, but let me be honest. When we have a press release about we are gonna do this, the Hopkins PR people are very, very hesitant to mention animals, lest they incite the public fear or PR. And mentioning baboon work, I wouldn't do outside this room. That's unpopular these days. That's unpopular in a lot of different circles. And, you know, the baboons are, I don't think people will go for using baboons for this. But for, you know, crying kidneys in a very small number, that's still okay. Even that's up for discussion. I'm hopeful that the selection of pigs, the intentional selection of pigs, will get around people's feeling that it's not appropriate to use pigs, but that, do you have any?
I have a very large stuffed animal pig collection.
I love pigs too. I think if somebody said, I don't eat pigs and I don't agree with their use for this, I'd be willing to hear them. Most of us do consume pigs or haven't thought to protest against it, so you're on less firm ground there.
So I think I'm in a unique position here of being the transplant recipient. And I would say I also happen to be mostly vegetarian. I would, in a heartbeat, if I was still waiting, take an animal organ, I would even hesitate. So
You are fantastic in many different ways. This is a discussion for ethicists to have, healthy people to have. We can sit around and have the luxury of saying, oh, I don't think I'm for this. When you are sick, it's go time and you need help and there's not enough help available. That's why we're not doing this for fun. We're doing this out of desperation. And people that are sick understand it. And we have patients on the list, they die on the list waiting. And it forces us to push.
Can you give examples of candidates who have been deemed not to be
Yeah.
human organ transplant? Comorbidities, social issues?
Excellent, that's the question. So I'll also be honest. When the study was first designed, the clinical trial, it was only for people that had gotten a no. This second cohort of patients that were on the list but weren't gonna get one in time, it wasn't even for them. It was actually kind of hard to find patients that had been looked at by 20 folks at Hopkins and said you shouldn't have a human transplant. For one of the following reasons, which we'll get to in a second. But lo and behold, you should have. That, so who would that be, right? So the reasons why you don't get a yes for a human kidney transplant you badly need, or you have some horrible comorbidity and you'll die during the transplant. You have a bad heart, you have a bad liver, you have bad lungs, you can't get a transplant. Obviously, it wouldn't help any to get a pig. It'd still presumably be at high risk. Or a lot of people can't probably take care of a transplant on the back end. They don't have a social network ready to take care of them. And so it's not a winning proposition. It's not gonna work there either. Or, for example, you know, they've been judged non-compliant. They're not gonna take their medicines. None of that would work for a xeno. So what is this window where you're not good enough for a human, but you are perfect for a pig? There's a couple examples. Number one, if you need an organ transplant, but you develop an unrelated cancer, you're on the bench for 5 years. So let's say I need a kidney transplant, but I have a stage 1 breast cancer in a woman. She's got to wait for 5 years for a kidney transplant. That's probably bogus. And you would be better off spending the next 5 years with a transplant and on dialysis. And we have reasons for saying no, but it probably would be better for you to have a transplant. And people that got a weird soft no probably should get a transplant anyway. There are people, this is scientifically interesting, that have, either because they were previously pregnant or got blood transfusions, have a monster amount of antibodies against other humans, and they're almost untransplantable. So the woman at NYU that got the second kidney was a very interesting story. Tamara Mooney had been a donor to her mom of a kidney. It subsequently had terrible diverticulitis, had been septic and lost her other kidney. She needed a transplant. She was highly sensitized and had been on the transplant waiting list for 10 years. And she had so many antibodies that she would never get a human transplant. Turns out the antibodies against other humans versus the antibodies against pigs are totally non-linear, non-related. So she was a horrible candidate for a human and was a perfectly good immunologic candidate for a pig. So there could be people that are weirdly best appropriate for a pig. It's not going to be a ton, but there's going to be some. But you're right, there's not that many people that the doctors at Johns Hopkins that said we'd love to transplant people who just can't, but then lo and behold, we could get you a pig. Some of the decisions we make are because there aren't enough to go around. And so we play it safe with some of our people that we list in transplant. There's also a requirement that you have a certain outcome. You have to have 95% survival or else the government comes and shuts you down. Those rules could be relaxed in the era of unlimited resources. If the pigs were literally endless supply, you wouldn't have to make some of those decisions. You would be more liberal.
Doctor, are these pigs identical,
Yeah.
I mean, so nothing could be wrong with one specific pig.
They're cloned. They're all the same pig.
Exactly.
They're all genetic clones. They're all blood through bone. They're all perfect. They're all sterile. None of them have viruses. They're all perfect. They're both. I mean, they're male and female. Got it? You got anything else? Yeah.
Is that specific to each of those companies? Or are they always both?
They're always both. When you clone a pig, you get piglets, and they're male and female. And I'm not as knowledgeable about eugenics, but I know the Revivicor and therapeutics system really, really good. And they're world-class scientists, and it's very interesting what they've done.
And they never get sick in the wherever they're farmed.
They do get sick. This is sort of more inside baseball. The knocking out the growth hormone receptor makes them a bit frail. And it's hard for them to breed. The FDA initially said you can't use clones. You can make these pigs and they have to breed and you can only transplant from the kids. And the animals that had the growth hormone receptor were kind of too frail to breed. And so the FDA said, fine, just use the clones. I think in the next iteration, they're not going to use the growth hormone receptor because the animals just don't grow that big. That was a theoretic concern that never came to pass.
Happens at just growing the organ.
It's too hard.
Yeah.
You can make cells in a dish. So I have diabetes, I need insulin, here's some islet cells. I bet that'll work. The 3D architecture of the liver or the kidney is so complicated that it's decades and decades away. But again, I call me when it's here and we'll put those in.
Are you one big for all three organs, for all three?
Where this study at Hopkins is only kidney. We are very, very, very interested in doing hearts at Hopkins too. In some ways, I think hearts is almost more exciting because there's dialysis. Dialysis is hard, but it's a thing. You're not gonna die this weekend. Nobody needs an emergency pig kidney transplant. But if you need a heart transplant, and you can't get one, you die this weekend. And so hearts are very compelling. Liver is scientifically more complicated.
But don't you think this is the best route because you're seeing paper? I mean.
Oh, for sure.
Right.
Oh, no, you gotta walk before you can run. There's no, I don't even know if I had the stomach for doing hearts. Because it's not gonna work forever and you guys take time. Kidney transplants, you can do a kidney transplant, you can learn a ton from, you can help the person get off dialysis and they can plunk back on dialysis. They haven't lost anything. They haven't lost a place in line for a human transplant. They haven't developed antibodies that'll make them less likely to get a human transplant. What I think is maybe the interesting question is, you call Mrs. Smith up, she's out for a xeno, she's on the list, but she's not gonna get one for 5 years. She gets a xeno, it works like a charm. 6 months later, she's doing great. Then she gets a call one night, we have a human transplant. What do you do then? Bring her in, take out the xeno that's working great and put the human in, or she says, I'll stick with the xeno for a while. That might happen. She's unlikely to get a transplant, that's why she was selected, but sometimes people that are unlikely to get a transplant, the lottery ticket comes in. And I think we have to call her up and say, hey, we probably should get that pig out to get a human, because right now in 2025, the humans work better than pigs.
Just a research ethics question. For these upcoming clinical trials, if like a woman would like to participate, would they have to be postmenopausal? And what is the
Great question.
ethics behind it?
They have to be non-childbearing. You have to be, I didn't list all the inclusion and exclusion criteria. You have to be between 55 and 70 years old, BMI this, all that, but yeah, you cannot be of childbearing. Good question. The FDA is way more careful than you might guess. They were actually really good partners and very knowledgeable and sophisticated in helping us design this study. What's surprising? Very hesitant to give the government credit at any point in time. We now know that
We'll probably have to end.
Okay, so if anybody has any more questions, email me, come find me. Thanks a lot for your attention and